and we're going to talk a little bit about patterns now. Now, patterns themselves can be used for obviously very simple things or very abstract things, depending on whether you use basic linear or circular patterns, or whether you use things like curve-driven patterns, sketch-driven patterns, or fill patterns, which are another exotic way to do this. I'm going to go ahead and start off with just a basic linear pattern, and you're going to quickly see just exactly how powerful a simple seeming addition to this tool happens to be. What we have here is a basic rail. Now the rail, of course, has a hole that we have down here, and then that hole was linear patterned. In this case, it happens to be 30 instances. Now, it's a great cut feature, but what happens when we take this rail and we change its dimension? Let's drop that from 1800 down to 800. Well, now what we get is a failure for the linear pattern. If a cut feature can't find a body to cut, the cut feature fails. So let's go ahead and edit this pattern. Now, since the beginning of SolidWorks, we've always had the spacings and instances as the control for how you do a pattern. How many do you want? What's the distance in between those? Well, now we have this new one called up to reference, and what this effectively does is it really replaces what could be between 3 and 6 equations to accomplish what I'm about to show you here. And it has to do with controlling the spacing between these instances and maybe when new ones are going to show up based on the length of this linear slide rail. So in this case, what we're going to do is two things. First of all, I'm going to add the up to count, the reference. In this case, it could be a face, an edge, or a point indicated by this icon. So we're just going to say up to this point. Now by doing that, what we get now is a pattern that's going to live just within the domain of the starting face and this endpoint. On top of that, what we have also is an initial spacing. If you look over here, this is 25 millimeters off the beginning of this rail. Now 25 millimeter start is probably what we're going to want on the other end too, so we want 25 millimeters down here. And I could easily type in 25 in this offset distance box, but it's really easier or better for the system if I just make this an equation. Now equations can happen just by hitting the equals button. As you can see, the tooltip pops up and tells us that. And when you hit equals in any dimension dialog box, you'll get all logarithmic functions, the file properties we calculate, and everything else within the software, global variables that you might have added. Well, in this case, I'm going to be very simple. I'm just going to say that this dimension equals, and then click another dimension on screen. So now D4 at sketch 2 and D4 at sketch 2. We change one dimension, we effectively change both offset ends. Okay, so that being the case, we have 60 millimeters up to and offset from an endpoint. So here's the effect that you get. Now when I start to grab this slide and drag it out, as I get 60 millimeter spacings plus 25 millimeter offsets, new holes will appear. So this is a very intelligent pattern when it comes to the method that it's created, first of all, but just the fact that this part as a configurable type of part can be used in an assembly of varying lengths, and you'll get an instance count update proper for those individual lengths. Now this isn't the only way to define this. If we go back into that linear pattern, instead of it being defined by the distance, we could also define it by simply number of instances. Now using the same references, what this is going to do, say we've got 25 of those, is it's going to automatically change the spacing based on the overall length. So here we need to keep 25 of those, but as I go ahead and start changing the overall value of this, it's going to update the spacings to continue to keep those equal. So really both disciplines of whether common spacing, variable instances, or common instances, variable spacing need to be addressed. If I want to take this to a different direction here, we're going to show you where editing a feature doesn't hurt you in the pattern instances anymore. We've got a single-bodied part currently. It's just a single merged solid, and this happens to be a saw blade with saw teeth. Well, I'm going to edit this sawtooth feature and turn off merge results, which will then turn this into a multi-body file. Well, this tooth as an extrusion, as a feature, was patterned. If we take a look now in the feature manager, we now see that that pattern breaks. And the reason being is because the carbide tooth that used to be a feature is now a body. On previous releases, we'd have to delete this feature and redo it, which could be a really big problem if there's a lot of children beneath that. But here, we can now go ahead and edit that pattern feature, and we have the controls to be able to say, I don't want this to be a feature pattern anymore. Instead, I want it to be a body pattern. That way, anything related to this is still going to update properly, and we can then we can really nimbly change from a single body part to a multi-body part and not really hit ourselves with a whole bunch of editing that might have to take place. So really simple, but that one there is super, super effective. We're going to change